All right, we're back. We're still on page 66, and we're doing compositions. We're doing compositions this time that start with an inverse, then go normal, then go inverse, then go normal. So our answer is going to be an angle. So let's see if we can do this. Just a piece at a time, right? So we're going to focus in on doing this first. So the inverse tangent of the cotangent of something. So I don't know. Let's see if we can do it. So first, it's going to be the sine inverse of the cosine of the inverse tangent of, we're going to cofunction this, the tangent of pi over 2 minus 10 pi over 7, 1, 2, 3, 4. All right, so simplify that. Sine inverse. Oh, I could copy this. I forgot for a second. Tan inverse of the tangent of, so 7 pi minus 20 pi is negative 13 pi over 14, 2, 3, 4. So we are done if, well, we're not done. We're done with this small part if the if negative 13 pi over 14 is in the range of inverse tangent, but unfortunately it's not. So let's draw our picture. So we're using 14, so 7 pi over 14, negative 7 pi over 14. Negative 13 pi over 14 is like here and has a reference angle of pi over 14. The angle that we want has the same tangent as that. So tangent is positive in the first quadrant and the third quadrant. So the angle that we actually want is this angle. So we actually want pi over 14. Okay, so that's what that's going to collapse down to. So now we got the sine inverse of the cosine of, so we just collapse this all down to pi over 14, which hopefully is right, because cofunctions, because they're not the same, right? So sine inverse of the sine of pi over 2 minus pi over 14. So this will become the sine inverse of the sine of, so it's 7 pi over, so 7 pi minus pi is 6 pi over 14, which is 3 pi over 7. So if 3 pi over 7 is in the range of arcsine, it is our answer. So let's draw our picture for arcsine. I mean, you probably already know the answer to that. Like, it is in the range. So that's what you're going to get. But so what's half of 7 is 3.5. And then negative 3.5 pi over 7. So 3 pi over 7 is like here. It works, so that's going to be our answer. 3 pi over 7. Let's go to the calculator and check it, right? While it's fresh in our minds, let's see if we can check this. So I'm just going to put it in one shot and hope that it's right. Arcsine of the cosine of the arctan of the cotan of 10 pi over 7. Oh, 17. Ah, the whole problem is wrong because I wrote 7 instead of 17. What do I want to do? Do I want to just like fix it? I don't know. I feel so defeated. If it can I just change the problem? Does anyone object to that? I think I might. But what if it's, no, it couldn't have been any easier, right? So like, let's just change it. Let's say that, how do I cross something out? I'm gonna cross it out there, just 7. There you go. Perfect. All right, so I didn't realize it was 17. That's a bonus problem for you to do. Let's try the next one. So same idea. So except this time I'll try to copy down the correct thing. So this will be the tan inverse of the cotan of the sine inverse. It's so weird that I thought, like all the way through, I thought that. I wonder if I go back and watch the video if I like ever said the right thing. Pi over 2 minus 19 pi. I wonder if that made it easier. It's like, it could have been much easier because we had to like, you know, go from one quadrant to the next, and then like the answer did work out, so that was nice, but like, I don't think we made it like substantially easier. And that's all that would really matter in terms of like getting your practice in. All right, we accomplished the goal of making these functions the same, sine, inverse, and sine. So this will be 10 minus 19 is negative 9 pi over 20. 1, 2, 3, 4. Negative 9 pi over 20, like you can feel is going to be in the range of arcsine because negative 10 pi over 20 is like an obvious fraction. So you don't have to do the like what's half of the denominator thing. Well, I mean, you're doing it, but you don't really need to because it's a good one. So there, so that actually works out. So now we're doing the tan inverse. That doesn't say tangent. Well, I mean, maybe it does in some twisted way, but not obviously. Tan inverse of the cotangent of negative 9 pi over 20. Hopefully there are no like egregious errors at this point. Hopefully. Man, it must have been killing some people who are watching. Just like, no, you're doing the wrong thing. No. And there's nothing you can do about it. So minus negative 9 pi over 20. So that's interesting. It's not a problem. I mean, you can still do it. So this becomes the tan inverse of the tangent of, so 10 plus 9 is 19 pi over 20. That feels suspiciously familiar. Why is that? Sine inverse. It's got to have something to do with all the like cofunctions, right? Like something to do with that. That we did like inverse tangent of the cofunction of tangent, inverse sine of the cofunction of sine. I don't know. It's got to have something to do with that we got back to 19 pi over 20. That's really interesting that we did. So if 19 pi over 20 is in the range of inverse tangent, which it's definitely not, it'll be our answer. If not, we have to think about it more. So here's inverse tangent. 19 pi over 20 is like here. And so this is 19 pi over 20. It has a reference angle of pi over 20, right? The little reference angle here. So I need the angle that's in the range that has the same tangent as this. Well, in quadrant 1, everything's positive. In quadrant 2, only sine and cosecant, then tangent and cotangent, and then cosine and secant. So tangent's negative, so I need the quadrant where tangent's negative that's in the range. So that's going to be the fourth quadrant. And I need the same reference angle. So here I'm going to use negative pi over 20. So I think barring something weird, I think the answer is going to be negative pi over 20. So maybe the weird thing is that I read the problem wrong again. Who knows? Let's see. So I'm doing, what am I doing? So I'm doing, you know what, did I never even check the last one to see if I had gotten it right? No, I think I got so defeated by the fact that I had done the wrong problem. Let me see. Maybe I didn't even get it right, and that'd be great. 10, 4, I don't know. 3 pi over 7. At least we got it right after that soul-crushing defeat of having misread the problem. So, you know, double check the problems that you're doing, which I never do until it's too late. 19 pi over 20 is negative pi over 20, which is what we got. So good job to us. So I don't know. It's like we did one right. We did 2 problems correctly. We just didn't do the 2 correct problems, which that's an issue. People on quizzes, people do that all the time. They accidentally misread it. Then it's like, I don't know, did you make the problem easier than it should have been? If so, that's a problem. If not, it's like, do I have an infinite amount of time to just look at your work and see if you did it right? If I do, I'll like take a look. Who knows? Just don't do it, right? Like we all learned our lesson right here. We're not going to do it. This is the approach that I used, just a kind of a summary. You don't need to use this approach, but this approach works. So why not? So step 1, you're going to co-function your way to the same functions, right? Sine and cosine, nope. Arc sine and sine, arc cosine and cosine, arc tangent and tangent. You want to get the same function involved. And then once you have that, what you can do is you check the range. And I use the unit circle picture for that. I draw the angle that I found, and I draw the unit circle picture. And if it's in the unit circle picture and you didn't have to go the wrong way to get there, it's the answer. Otherwise, you just have to use some reference angles and your quadrant ideas, the range of the inverses, and you will get the answer that you were looking for. So this is the method that I use. You're free to use whatever you want as long as it's working for you. These problems are great because they really make you think about cofunctions, reference angles, quadrants, all of your inverse functions. Like there's a lot to think about. So obviously I like those because I like to think about this stuff. So I'll be back in the next video, which I think is just really a summary, and I'm kind of excited about that. So I will see you there.